Hello, my name is Emma, and welcome to Design Patterns in Minutes by dpatterns.com. Today, we're exploring the interpreter design pattern, a fascinating pattern that lets you define a simple language or grammar and use it to interpret and evaluate sentences written in that language. Think about how calculators, SQL engines, or even search filters understand what you type. When you enter 3 plus 5 times 2 into a calculator, it doesn't magically know math. It interprets the symbols according to a defined grammar. The interpreter pattern gives your code the same kind of capability to read structured input, understand it, and perform actions based on its meaning. Here's the core idea. You start by defining a grammar for your mini language, a set of rules that describe how valid expressions are formed. Then, for each type of expression, you create a class that knows how to interpret that piece. When the system reads input, it builds a structure of these expression objects and then evaluates them one by one. Let's take a simple example. Suppose you're building a rule engine for access control. Something like, user is admin or user has permission and account is active. Each of these keywords, user, permission, account, can be represented as an expression object. The interpreter pattern lets you combine and evaluate them dynamically, giving you an easy way to define and execute complex rules at runtime. Another common example is in math expressions or scripting. You can define add expression, multiply expression, and number expression classes. When you parse something like 3 plus 5 times 2, you build an object tree that represents the structure of the formula, and then the interpreter evaluates it correctly according to the rules you defined. The power of the interpreter pattern lies in its clarity and flexibility. It gives you a consistent way to handle structured data and rules without hard-coding every possible combination. It's great for implementing mini languages, configuration systems, query engines, or anything that needs to interpret expressions dynamically. However, there's a trade-off. The interpreter pattern works best for simple grammars. If the language becomes too complex, the number of expression classes can grow quickly, making maintenance harder. In those cases, parser generators or other more advanced techniques are a better fit. To summarize, the interpreter pattern lets you define a grammar and build an evaluator for it, giving your code the ability to read and understand structured input. It's perfect for rules, filters, queries, or small domain-specific languages. Thank you for listening to Design Patterns in Minutes with me, Emma. For full explanations, diagrams, and code examples, visit dpatterns.com.